In the world of microprocessor architectures, there are two big players. We have Intel, big in desktop computers and servers, and there's ARM, big in the mobile world. They both have their own instruction set architecture and intellectual property rights to secure their investments. Is there room for another player? We talk with Krste Asanovic, one of the founders of SiFive. We all know Intel, we all know ARM, but not many people will know SiFive. Can you tell us a bit more?
Yeah, SiFive is a company I founded with two of my ex-students, Jens Lee and Andrew Waterman. But really the story of SiFive is trying to, as is apparent in the name, build silicon versions of RISC-V. So RISC-V is a new instruction set that we developed in my group at UC Berkeley and now is seeing a lot of widespread adoption throughout industry with the backing of the RISC-V Foundation, which is an independent nonprofit that manages that RISC-V instruction set standard. So at SiFive, we're building custom processors and custom core IP around this RISC-V standard.
Okay, what will it take for a relatively small company, but how many people are you?
So we're about, I think, 34, 35 right now, and we're hiring. So we're looking to grow.
Good.
And here in our office in San Mateo, we have about 34 people right now.
Okay. What will it take for such a relatively small company to pick its place in history? I think you're doing quite well. You're making a lot of waves. But what will the big next step be for SiFive to put more pressure on open standard, open source, and RISC architecture?
Yeah, I think we're seeing, we're riding the wave of RISC-V adoption. So throughout industry, a lot of people are seeing this as a very viable and valuable alternative to the existing commercial ISAs. I think the big advantage the customers see is by moving to RISC-V, they can first pick the instruction set and then later choose a vendor. So they get the freedom, they're not locked into any one particular design point, the design vendor. They can build a processor using a RISC-V core. Second generation product, they can go back out and have people recompete over that. So the context of SiFive, for us to be successful, we want to have the best and the fullest range of RISC-V cores out there for people to use. So we focus on very highly efficient cores that are standards compliant. A lot of us are highly involved in writing the standards. And also we are a silicon company. We're the only company that's produced RISC-V silicon. And so that knowledge from actually producing the silicon helps us build better core IP as well that we can sell to people. So we hope to, what we like to do is build a whole community. There's many vendors now, RISC-V cores, and we work together through the RISC-V Foundation, given this standard. So our customers all can appreciate this, choice they have. And there's many, many niches. We don't want to, we don't have to take every single RISC-V socket. We'd like to grow the whole RISC-V economy. But for SiFive in particular, for us to be successful, we want to focus on a few of these areas.
Yeah. What sort of applications do we need to think of if we're talking about the SiFive developments? What are typically applications?
So, I think most of our customer engagements have been focused on the core IP, the soft cores that we're selling. We're seeing a lot of interest in what we call minion cores, which are an embedded core that sits on a larger chip. So if a company is making a large SoC, there's often a need for a lot of housekeeping cores on there. And so some of our customers are in that space. Other customers are more traditional microcontrollers. They're small systems where this core is the only core on the chip. And some other areas we're seeing interest are in data center accelerators. So this is where there is a device that sits next to a Intel server in a data center attached over PCIe, for example. And the different acceleration functions there might be, we see three big areas. One is machine learning, AI accelerators, where the RISC-V vector extensions are very interesting. The second area is seeing a lot of activity in storage controllers. This is flash, SSD devices, and also the new non-volatile memories. There's a lot of activity there. And also in network processing, so network accelerator functions.
Yeah.
So those are kind of the three areas we see a lot of interest in the data center acceleration space.
Sure. But I also read at Fosdem you're also opening up some new developments with the HiFive Unleashed board, which is basically a Linux board.
We want to be the leaders in the RISC-V community, and one of the things the community has needed is a real piece of silicon to develop Linux on. So I have one here. So this is what we announced at Fosdem. This is the HiFive Unleashed board.
Yeah.
And this contains this is the first. Well, for one thing, it's only the second piece of commercial silicon for RISC-V. The first piece was our HiFive 1 board, the little Arduino compatible microcontroller. This is a 32-bit microcontroller meant for that space. This board has our FU540 SoC on there, and this contains 4 Linux-capable 64-bit cores with a cache-coherent subsystem, as well as a 5th embedded E5 core, E51 core, which uses a management core, secure boot running the system. And so those 5 cores are on this chip together with a DDR4 memory interface. And so on this board, there's 8 gigabytes of DDR4 memory, as well as a gigabit Ethernet port coming off this board. So this is really a Linux development platform.
Sure.
And we're really selling this. People are wondering, why is it $1,000? Why isn't this a $30 Raspberry Pi level board? And the reason is this is early days for RISC-V, and really want to focus on the serious developer community, people who are building out the Linux ecosystem and attaching devices. And also for our customers. At SiFive, we customize cores and add custom engines to the ICs. And so what we did with this part is we added what we call chip link, which is a open standard chip-to-chip cache-coherent interconnect that basically takes our TALink standard and extends it out over, on the back of the board, there's an FMC connector.
Okay.
And you can connect this to an FPGA, and on that FPGA, you can have your own IP, other IOs like PCIe comes out over there. We demonstrated a Fosdem running accelerated graphics with a PCIe graphics card, standard graphics card attached to that secondary FPGA. So the idea is this SoC will be used to partly for the community to boost the development of RISC-V software, but also by our customers to develop new IP that they'll connect with our cores, and then we can build a custom SoC for them based around this design.
Can I ask, there are 8 shiny connectors there, small connectors. Where are they for?
All right. So everybody's asking about the nice gold shiny pieces. So
of course.
These are SMA connectors. They're for our internal bring up and debug of the memory controllers.
All right.
So it has a very high speed DDR4 interface. And that's to help debug that, as well as a few of the other clocks and other signals. So yeah, this is a very high performance chip. It's 1.5 gigahertz for the cores, plus high speed DDR4 memory interface. And it's also a 72-bit ECC protected DRAM interface. So it's quite a serious board, which is part of the reason why it's quite expensive. But we wanted something to, because a lot of our customers are working in that higher end space to support them.
Yeah. Okay. And the more people order the boards, at some point the price will go down.
Yeah. So this is a first development chip. We obviously have other chips coming along in the pipeline, and those will be more cost reduced, more complete in themselves as a standalone product. This is really meant to help develop new chips. You'll be seeing a lot from us in the future. We have a lot of chips in the pipeline.
Okay. On the promotional side, you will be at the Embedded World, I think, coming up in Nuremberg.
Yeah, I think RISC-V will be there in force. The RISC-V Foundation. Well, I think some of the key things to go check out at Embedded World are the third-party tool suppliers. So when people build these cores into their systems, they need support. And there's companies like Lauterbach and Sega, for example, provide tool support now for RISC-V. I think that's a sign of the maturity of the RISC-V market now. The third-party players are coming in and supporting it based on customer demand. So customers are coming to these established companies in the tool space and saying, can you support our RISC-V developments? And they're responding by having these products out there. So that's an indirect measure of the penetration of RISC-V into these markets, the fact that these third parties are now seeing demand for that kind of product.
Okay, good. So clearly, RISC is on the rise, to say it in easy words. Thank you very much for your time and for your explanation.
Thank you. Okay, bye-bye.
Okay, bye-bye.